Hey guys, I just thought I want to just finish up these notes here. I did a couple example problems in separate videos at the end. Really, this video is 3 example problems, but just as a reminder, we're doing this binomial expansion, which is an expansion of an expression that looks like this. And we just discovered there were like a bunch of terms here. It looks something like this. And this is going to look like this. The last C is a 1, and then this is going to be no A, it's going to be B to the end. So they look like this, but the trick to remember is that there's 3 components to each one: a coefficient, some power of A, some power of B. And we get the powers of A just by raising A to the power. We get powers of B raising A to the power, and we get these coefficients, the C1, C2, all those things. These are NCRs. They are combinations, or they're from Pascal's triangle. The reason I want you to know how to do it this way is because there are going to come problems where you're not going to be able to use Pascal's triangle. They're going to be very large numbers. Like if I said like an A plus B to the 30th, tell me the 23rd term. This is a problem, and you're not going to want to have to figure out the 30th row of Pascal's triangle because that would take forever. So instead, that's when you would use NCR instead. But for the smaller ones, you can use Pascal's triangle. In the examples I'm about to do, you can use Pascal's triangle. So I'm going to write it here off to the side, so we just have it. This is a 3rd power, and that's a 4th power, so I got to get at least to the 4th row. That's the 0th row. That's the 1st row, 2nd row, 3rd row, 4th row. So for this first problem, I'm going to be using this row. And for the second problem, I'm going to be using this row. So let's just get to it. The trick here is we have a coefficient, which we know this is the 3rd row, and that's the 4th row. The 3rd row, I'm going to use 1, 3, 3, and 1 for my coefficients. So I go 1 plus, and then, sorry, I did just one thing. There's 3 components, so I just did one of them. 1, and then a power of x, and that always starts at n, starts with the biggest number. Then a power of the second thing, which always starts at 0, so that these 2 add up to 3. The next one is going to be the second coefficient, which is 3 times x now to the 2nd power, and then 1 to the 1st power. Again, this one went down by 1, that one goes up by 1. I'm going to take the next coefficient in my row, which is 3. Then I'm going to do it times x to the 1st, that goes down by 1, and then times 1 squared. And then my last coefficient is always 1. It's always x. This always has now become a 0 power, and the 1 is raised to the 3rd power. You can see like the exponents have like exchanged by the time they get to the end. X was 3 and 1 was 0. Now x is 0 and 1 is 3. Now I just kind of simplify. All these 1s here at the end are just 1, so I don't have to worry about them. This is 1 times x cubed times 1, which is just x cubed. This is 3 times x squared times 1, so 3x squared. This is 3 times x times 1, which is just 3x. And then plus 1. So good to go. We're going to do a similar thing here with b, with x plus 2 to the 4th. The only difference is that I'm going to be using this 4th row. And now instead of having a 1 here and all these 3rd spots, I'm going to have a 2, which is going to change the coefficients a little. But the basic premise is the same. Coefficient times the power of the first thing, which this time is 4, because that's a 4 now, times the power of the second thing, always starts at 0. Now I'm rolling. I just keep decreasing this power by 1 and increasing that power by 1 and plugging in the correct coefficient. So 4, decreased power of x, increased power of 2. 6, decreased power of x, increased power of 2. 4 decreased power of x, increased power of 2, and then 1 decreased power of x, increased power of 2. And again, it was x to the 4th and 2 to the 0, and now it's x to the 0 and 2 to the 4th, and that's always going to happen. Now I simplify, that's a 1, so this is 1 times x to the 4th, which is x to the 4th. 4 times x cubed times 2 is 8x cubed. 6 times x cubed, this is really a 4, so it's 6 times 4. The coefficient is 24, and the power of x is x squared. This is 4 times 3, sorry, 4 times 8, 4 times 2 to the 3rd. 4 times 8 is 32, and that's x to the 1st, so just x. And then the last one is 1, and 2 to the 4th is 16. So this is what this expansion would look like. If you had to multiply all this out, you'd collect a bunch of terms, and they would all look like this. One thing that I think is important to notice is that the coefficients in Pascal's triangle were this, and those are no longer the coefficients because this number came into play. You can see it was like 2 to the 1st, so it became 8 instead of 4. So while this first one, it was 1, 3, 3, 1, just like we expected. That doesn't work if there's a number here that's not 1. Now the third example I like because there's a coefficient in front of the x and there's a negative, which gives us 2 new concepts to deal with. The first one is the negative. When you have a negative sign here, what I recommend you do is you alternate the signs of the coefficients. You don't have to change the values of the coefficients like the numbers, but you have to change them from positive to negative. And you'll see this as we start doing it, but it saves you from having to worry about raising -1 to a power. We're just going to raise 1 to the power. And if we alternate the signs, that'll take care of the fact that we're using +1 instead of -1. So this is the 4th power. So I got to use that 4th row again, which I think is 1, 4, 6, 4, 1. These are my 5 coefficients, which I think checks out. Then I'm just going to do a coefficient times the power of this times the power of that. And I'm going to remember to alternate the signs. So this is going to equal, first coefficient is 1. First power is going to be 4. And then times 1 to the 0. So again, coefficient, power of the first thing, power of the second thing. And now again, I'm off and running because I have these coefficients. I can just decrease this by 1 and increase that by 1. But I have to remember that this negative sign means the first term is positive and the second term is negative. Coefficient though is 4 like it was before. I have 2x to the 3rd, that went down by 1. Here we have x1 to the 1st. Then I do an adding, and I get 2x squared, and I get 1 squared. Then I subtract, because I'm alternating signs, 4 times 2x to the 1st, times 1 to the 3rd, and the last one is positive, 1 times x to the 4th times, oops, sorry, that's wrong, x to the 0 times 1 to the 4th. This is another one that's a little easier because I don't have to worry about these at all. Those are all just 1s. But I do have to worry about the fact that this is 2x to the 4th. This is 16x to the 4th. The 4 applies to the 2 and the x because it's in parentheses. That's why I've always written it that way. So make sure when you're figuring out these coefficients, you're taking into account the fact that the 2 is raised to the 3rd power in this one, and the 2 is raised to the 2nd power in this one. So what that's going to look like here is 1 times 16x to the 4th times 1. Oh, so I'm done. Now the coefficient here is 4 times 2 cubed. That's 4 times 8, which is 32. The coefficient is not 4 times 2 because the 2 is raised to the 3rd power. So I get 32, and then x is raised to the 3rd power. I should expect the powers of x to keep decreasing by 1, and they will. Coefficient here is 6 times 2 squared. So plus 24 x squared. That went down by 1 like I hoped it would. This is 4 times 2 to the 1st, which is actually just 4 times 2, which is good. So that's just 8x. And then the last term is 1 times 1 times 1 is just 1. So this expansion looks like this. The important thing to note here is that, to remember, is that when I have something, a number in front of the x like this, I got to raise that number to the power as well as the x to that power. That's a very common mistake, and I would like you guys to avoid it if you can. So the two examples have more of this. I think they're probably really helpful. I hope that this was helpful as well.